Not much to say about myself.
Yeah.
So I have a presentation. If you don't mind, I can.
Yeah.
Let me go
directly
to the presentation. There's.
Please. The floor is all yours. Yeah. And about
So,
questions, do you want to keep it interactive? Do you want to wait till the end? What is your preferred format?
whichever way you people are comfortable. So I don't have any preferences.
By the way, in all of Pan IIT meetings, when I meet IIT Kanpur young students, when I tell them Professor Vyas is our hostel mate, they all give us an additional degree of respect.
Look, is it visible?
Yes, it is. It is.
Yeah. So
You're on, buddy. Yeah, cool.
Okay. So I'll talk about the work that I have been involved with in from IIT Kanpur over the last uh, decade or so. In fact, I superannuated on 30th of September this year, and I am no more a regular faculty of IIT Kanpur.
Yeah.
So, but I will continue as emeritus till the end of till the age of 70.
Very good.
Nice.
Very good. Congratulations.
So,
Recording in progress.
I intended to move out, but my wife being here, she has another 5 years to go as a medical officer, chief medical officer at the health center at IIT Kanpur. So I'll stay back, and my main job would be to move around with her and holding her bags. So, well, after I've been at IIT Kanpur for the last 37 years now. Joined here in 87 December. And but my identity still remains room number 271, hostel 6.
Very nice.
IIT Bombay. So that remains my identity. I have been involved with some of the activities at the national level, railways being one of them. Space is another. I started my journey with some projects in defense, then automobile, etc., etc. Ours has been a group. As you know, my BTech was in mechanical, and and then PhD, MTech, and PhD at IIT Delhi. And my PhD was on rotor dynamics and turbo machinery. So, and then I've been a visiting professor at a couple of places. So that's about all as far as personal movement has been concerned. Ours has been a group at IIT Kanpur, which knew a little bit of mechanical engineering and dynamics, machine dynamics in particular. A little bit of sensors and instrumentation, a little bit of signal processing. Then we started doing neural networks and expert systems way back in 1999. So IoT in general, with a background in mechanical engineering, so it has served us very well in various domains of technology. So let me come to what is going on presently in the country. I prefer to call it India 4.0. And as we all know, India missed on the first industrial revolution. which happened with the advent of steam power, and this revolution was propelled through steam power, and that is the time 1760 to 1840. 1760 is around the time when India was under the rule of Aurangzeb, and 1760 to 1840, while it coincided with the beginning of Europe's colonial conquest, whether it was Spain, Portugal, France, the United Kingdom, Britain. So we missed out on that. During the initial decades of our independence, we made modest progress in the second, the era which is now called the Industrial Revolution 2.0, with electrical power-driven machines. Our prowess, as we all know, and with our generation, which with the advent of computers, which catalyzed Industry 3.0. So though we made the considerable investment in several manufacturing sectors, we still do not utilize the full potential, and of the production efficiency in most of our sectors, whether private or public, is as low as 20%, and this is something that I have good data with me about. But now with the fourth industrial revolution, which is essentially an activity which integrates cyber-physical systems, cyber systems on one hand and physical systems on the other hand, India has the best ever opportunity not just to transform existing assets to provide high yield and high quality, but also to emerge as a global leader in smart manufacturing, which is commonly known as Industry 4.0. But this promise can become a reality only if it is aligned to India's Atmanirbharta paradigm. And this alignment is indeed happening now. So if you've been following the Prime Minister, when he talks about technology, his focus has been mostly on Industry 4.0. He is one person amongst the in the government setup in the country who understands and who speaks about Industry 4.0. I am not too sure about other members of the cabinet, but the Prime Minister is definitely has understanding of Industry 4.0, and he's mentioned and talked about Industry 4.0, whether it's in India in his Man Ki Baat or in his appearances abroad, including a meeting that he addressed in Chicago. So there is a great awareness, and indeed the Prime Minister himself has been the prime mover of the Industry 4.0 related activity in the country. If you look at, I'll come to these case studies in about 5 minutes after these generalities. So if you look at our national policy of advanced manufacturing, this is a document. It envisions that manufacturing should constitute at least 25% of the GDP. It is still not 25% of the GDP. Presently, it would be between 10 to 12% of our total GDP. And this policy statement also envisions a radical transformation of the manufacturing and infrastructure through a synergy between physical and digital technologies. And the emphasis is on utilization of existing assets rather than investment in newer assets, and utilization of the existing assets to whatever maximum that is possible. That has been the emphasis with adoption of the RAMS paradigm: reliability, availability, maintainability, sustainability, etc. So there have been mishaps, there have been setbacks in the, as you would have seen in the, we had recent accidents in Balasore, and then one again in Voltaire division. But by and large, the mark is on and is going on. So for a background, cyber physical architecture includes Internet of Things, cloud computing, cognitive computing, component and system design and dynamics, manufacturing processes, quality control, sensors, data acquisition, signal processing, neural networks, multi-objective optimization, fuzzy logic, convolution neural networks, and RAMs. And some of the domains that I have been involved in are railways and defense and the MSME sectors. And we've also developed an indigenous Industry 4.0 platform with both hardware and software protocols, and it is called Indus Tantra. I'll come to that after some time. We started our Industry 4.0 journey with the modern coach factory in Raebareli in the Indian Railways. And the objective was to develop and implement Industry 4.0 protocols for manufacturing processes for improved productivity and better quality and process flexibilities. So this factory in Raebareli is a huge, massive factory. Like any other big rail factory in the world, like CAF or Talgo or Alstom. But the productivity was about 400 to 500 coaches per year, railway coaches. The price of each coach is about 4 crore rupees, 4 to 5 crore rupees. With bits and pieces of implementation of Industry 4.0, they were able to jack it up to 1,200 to 1,500 coaches per year. When the Prime Minister visited this factory, he thought and he was convinced that the productivity of this particular factory, which is the latest in the group of coach factories, the first one being at Perambur and then Kapurthala, it should be around 5,000 to 6,000 coaches per year, which is eminently possible. Today, with our some contribution from us, we took up a project. It stands between 2,500 to 3,000 coaches, and the productivity has not reached higher than this because during COVID, the requirements of coaches, not just in India but the rest of the world, also came down drastically. So what you see here is the layout of one of the shops. This is the shell shop of the factory. So material would enter from this side, and this particular area has about 55 to 60 different machines, and this is where the processing of the sheet metal takes place. Welding would take place, and it is in this bay, and there would be another 15 to 20 machines where the assembly takes place, and the bare bones coach comes out of at this end. Now, when you talk of Industry 4.0, we did not understand much when we started this project. We wanted to have a platform where the machines could talk, where the material could be tracked, material could talk, and where the human beings, operators also could communicate, all on the same platform, which could also be integrated with their existing ERP, where scheduling could be done, where optimization could be carried out, along with monitoring the health of the machines for predictive maintenance. In fact, my involvement in this area started with way back in 1999, where we implemented a similar project for condition monitoring of a 210 megawatt power plant in the state of Punjab, in a place called Ropar, which is very close to Chandigarh. So here the problem is that initially we thought that we will invite Siemens or Dassault Systems and give subcontract to them to develop this entire platform for us, and our job will be to just to validate it and to see that everything is understood properly by our people. However, to our what we realized was that first of all, people do not have solutions to our systems, which are not greenfield factories. And secondly, the cost of implementation of this technology is prohibitively high. They would require just 2 crore rupees just to visit the factory and make an assessment of whether they can do it or not. We still have the quotations with us. And for implementation of the platform, if at all they were to do it, the cost would have been about 200 crores for just one plant like this. And the factory has nearly 1 dozen such plants: the wheels and axles plant, the electrical plant, the electrical shop, wheels and axle shop, paint shop, and so on and so forth, furnishing shop. So implementation of such technologies with imported stuff is next to impossible, and that is why we have not been able to implement the train control system till now, because we have relied on imports rather than trying to develop it ourselves like China has done. So and here the issue is that these machines are of different make. There would be machines of Siemens make, there would be Fanuc robots, there would be Heidenhain controllers, there would be Honeywell sensors, and so on and so forth. So a Siemens controller would not talk to Heidenhain, Heidenhain would not talk to Fanuc, Fanuc would not talk to Honeywell, and sometimes Siemens would not talk to Siemens itself. So that is a problem which even Siemens would not be able to solve right away. So we fill in a very, very good, very critical space with this platform that we have developed. We not only do make the machines talk on the same platform, we also do material tracking. We also develop human-machine interfaces. We do ERP integration, optimization, schedule optimization, and also condition monitoring of the health of the machines through deep learning and neural networks. So such requirements exist in the Ministry of Heavy Industries, where you would see if you look at the portal for if somebody has drawn a red line on my screen.
Oh, must be from your side because your
No, it's Bhimani.
Oh, acha, acha. Oh, let me.
So I don't know whether it can be removed or not.
I'll take care of it. Sorry about
Okay.
that.
Okay. Okay. So you see a lot of activity being envisaged in the Ministry of Heavy Industries, not just the railways. You look at the portal for Ministry of Heavy Industries. And most importantly, the Ministry of Micro, Small and Medium Enterprises, which is where the rejuvenation and regeneration of this traditional industries and traditional crafts holds the key for 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 transformation of the society, like it has happened in Taiwan, for example, like it has happened in South Korea. Uh, 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 there is Spurti is a scheme for regeneration of traditional industries, and this Ministry of MSME works through clusters. And if you see, there are about 300 clusters. And if you see in this table, there is an agro cluster, there is a bamboo cluster, there would be a cluster in Aligarh on locks, there would be a jute cluster, there would be a coir cluster, each supporting thousands of artisans and thousands of workers. It also includes automotive ancillaries, which form clusters in Jamshedpur, in Indore, in Ahmedabad. So they have more than 300 clusters, and they also have a program for end-to-end digitalization of these Spurti clusters. So this is where when I said that consciousness and has arisen and efforts are on the way in India. This transformation is happening. It is going to take place, whether we like it or not. It is going to take place. The only question is whether we are going to do it or Dassault Systems or Siemens or some such company is going to do that with a girl sitting in Malaysia controlling and all the data that from these sectors, and then telling us day after tomorrow what we should produce, how much we should produce, what machines to buy and what not. So there is an urgent need to make an intervention even for a group like this. It calls for a collaborative effort and putting resources together. So this program is for increasing of productivity and improving the income of marginalized artisans, and to make these clusters efficient, effective, and smart. And this includes various IT and IoT related work. I visited Polachi Coir cluster last year. This was during COVID, and this project is about to start. So coir is involves extracting yarn through
Husk.
From coconut, and it's a huge industry in Tamil Nadu and Kerala, in the region going from Coimbatore to Alleppey. It's a very big small scale industry, medium industry, where you ultimately get products like this. This Polachi area itself, this one particular coir cluster in Polachi, provides employment to 18,000 artisans. And an SPV has been formed. So there are several such SPVs. If you go to Coimbatore and LFP region, you will find 50 such SPVs which are in the PPP mode and which are crying for automation, and they are crying for state-of-art technologies and updating their systems. And this is a table that has been provided to us from one such cluster that you have current practices where there is machinery production with no intervention of digitalization. So machinery data needs to be digitalized. Suitable hardware for sensors and data integration. Analytics needs to be done for improvement of machinery performance. Energy optimization needs to be done. Energy utilization and energy efficiency is hardly 25 to 30%. Then all coordination between machine and materials is manual. This needs to be automated. Quality control. In fact, quality control is because they all face challenge now from China. Coir activity has shifted to China from India earlier, and it's a question of their existence. So coconut gets exported to China. It is processed there, and then again the finished product is brought back to India and sold in India and rest of the world. Because there they have been able to transform their systems, do better quality control, do better energy management, and so all such MSME clusters in the country require immediate intervention, investment, and effort. Now, another area of activity where I have been directly involved is aircraft health management, and that is with the light combat aircraft, which is called Tejas. So Tejas has been successfully developed, and it is flying. It is one of the smallest aircrafts, and it is an effort of many agencies coordinated by the Aeronautical Development Agency, ADA, in the country. So now they've embarked upon from Mark 1 to Mark 2. In fact, Mark 2 of Tejas development is in progress. Mark 2 and the Advanced Medium Combat Aircraft, AMCA, is the next generation aircraft that is under development at the Aeronautical Development Agency and the Hindustan Aeronautics Limited in Bangalore. And health management of such aircraft systems, which was not there in the earlier version, Mark 1 of LCA, is an important objective with improved, in fact, with implementation of diagnostics and prognostic methodologies for improvement of aircraft availability and reduction of maintenance period, because the maintenance period now is about 14 hours, which is not acceptable. The recent fleet of Rafale that has landed in India does not have an integrated vehicle health management system. They do have some management in bits and pieces, but we do not. We get the information and we get these signatures only in the form of process data, where they show us green, red, and yellow buttons that it is good, bad, or ugly. But the data is the raw data is not available to us. So this is a matter of very serious concern that the data of aircrafts which have been purchased by us. The control of the data is not with us. So ADA is developing the future next generation aircraft with integrated vehicle health management, and this has been the objective of ADA for a very, very long time. I'll take about 15 more minutes, Nat.
No, that's great.
Nice, nice.
Fantastic. Really thoroughly enjoying it. Yeah.
Go ahead, it is very interesting.
Okay.
Brilliant.
So this issue of integrated health management is whether it is aero systems or railways or automobiles involves large systems. So life cycle analysis in aerospace, railway, automotive processes involves condition monitoring at the systemic level. Condition monitoring and development of digital twins at the subsystem level has been thrashed out and beaten to death by several groups within the country for a very, very long time. It is the large systems which are a challenge. So condition monitoring activity at individual component level has been quite vigorous, and model-based, data-driven hybrid techniques have been adopted. The challenges posed at the subsystem level and from the individual component level to the subsystem level and from the subsystem to the systemic level, they increase exponentially, both in terms of the physical complexity and the enormity of the data collected by sensors. For example, here in the aircraft, you would have the landing gear, you will have the propulsion system, you will have the hydraulic systems, the avionics, the electrical systems, and each with several components. And now at least 100 sensors in the conventional aircraft, and in the advanced aircraft, thousands of sensors with data available everywhere. Similarly, you have for automotive, and I know I will not talk about automotive because though I had done some work in automotive for the national program on smart materials and structures, but in railways you have various subsystems with data available everywhere. The challenge is to utilize this data and make sense out of it at the systemic level. This is a slide which depicts the IVHM plan, Integrated Vehicle Health Management Plan of NASA.
Wow.
This is adopted by the Indian Aeronautical Development Agency also, and Dr. Kota Harinarayana, who's considered to be the grandfather of the Indian light combat aircraft. He uses this slide very often. At the base level of this structure, you have the fundamental technology of sensors, modeling and simulation, data analysis and algorithm, development of test beds. So this program has been taken up vigorously all across the country at this fundamental level. Then at an upper level where all these contribute to health management system development for general systems, airframe, propulsion system, avionics, software health management, and so on and so forth, which would do detection, diagnosis, prognosis. So detection, diagnosis is all very well understood. It is prognosis that people are working on. Mitigation is still a far cry, and integrity assurance. This is true for aircraft industry all over the world, not just India. And then over to the fleet level. So this gives an entire picture of what is meant by integrated vehicle health management. So in India, we've been working on groups have developed digital twins for the systems like hydraulic and landing gear system, engine management, in bits and pieces, not at times they are model based, at times they are data driven, at times they are hybrid models, electrical system, fuel system. They would be in terms of Simulink packages or neural networks or equation based. So let's say you have systems like a hydraulic system, each with its own set of components and subsystems, and then another system like this, brakes and landing gear, and another system, third system like this. This is all very well understood to a good extent. It is at the systemic level where the real challenge lies, that how are these related to each other as far as developing the digital twin is concerned. How would the lever at the pilot command would affect the stress at a particular point on the wing? That is the extent to which we would like to develop our digital twin. So these relationships and synapses between these subsystems is a very difficult task to determine and understand. So this is not the work of an individual, but a team of 6 persons who are dedicatedly working on these systems in ADA, and 2 or 3 persons here, 2 or 3 persons elsewhere in the industry, working together to build this system of systems. So our focus, my focus at least, has been understanding the dynamics of the system of systems and developing digital twins of this system of systems. So machine learning based framework for database digital twinning for operational parameters of the aircraft from measured subsystemic parameters is what we have been doing. And there are issues which are related to defining the architecture of the digital framework, and development initially of an offline database digital twin components, and then integration, their integration, diagnostics, and prognostic related activity. Our background and our experience in this dates back to 1999, when we first attempted neural network based condition monitoring project, which was done by IIT Kanpur, IIT Delhi, BHEL Hyderabad, and CSIO Chandigarh together jointly at this thermal power plant. This is one of the units in a bigger plant in Ropar. So here, those days, this machine learning terminology was not even coined, and people used to look down upon neural networks because they were considered to be black boxes, which rather than appreciating that the neural network is essentially nothing but a set of a large number of nonlinear equations which are being solved simultaneously. But we did this there. It worked for some time. We also implemented in Thai Power Company in Taipei. That was again around 2000, where data was taken from 21 different sensors in all along this installation: HPT, high pressure stage, intermediate pressure stage, low pressure stage, and the generator, acceleration signals, pressure signals, temperature signals, and then fed into a neural network for prediction of faults. These days, we have shifted to, and this involved processing through statistical processing in the time domain and frequency domain. Now we have shifted to deep learning of late for the last 2 years, where we do the deploy analogies similar to the image processing technology, where taking these signatures from bearing, gears, etc., and then feed them into this convolution network, which those of you who are not exposed to this, it works like this data, raw data, without any pre-processing, as it is collected by the sensors, is fed into this network, which goes deep.
Beautiful
This is
animation.
huh?
Beautiful animation, yeah.
Yeah. This is how data compression is also taking place, so that a huge amount of data gets compressed into a small nugget or a kernel. And you can take this kernel put this into your pocket, take the seed in your pocket. You do not need to carry the entire data also. And grow the tree anywhere you like. So this is what we have been doing, and just to show you how this crystallization or nuggetization is taking place from input. At the input stage, you have a large variety of signatures which are can be seen as coins of different colors distributed on a carom board, and with one strike. And as you go on striking it, the clusterization happens. And after, say, stages, this is up to 6th stage, where a large amount of scattered data has got nuggetized, compressed in this form. It also helps us to identify the various fault. This is fault identification also, that if an unknown signal would go and sit in this space in this trained sheet of network, one would be able to say that this is a no fault case, or a cocked rotor case in the rotor, and so on and so forth. So this is just about 2 weeks old, and this has been done by second year, third year graduate students.
Wow.
And this has been developed for practically no cost. AI-based automatic barrel bore inspection. This is Bofor's gun.
Nice.
This is Bofor's, and which is now being manufactured in the ordnance factory in Kanpur. This barrel of the gun is about 8 to 10 meters long, and it has a diameter of 9 to 12 inches. And this barrel, during manufacturing, develops the manufacturing is not perfect, and we see several such defects, like pitting, copper deposition, scratch marks, heat marks, because of which this barrel gets rejected. So they gave us initially a set of about 8,000 images, and they also wanted a camera system, a robot which could, with cameras which could crawl into this barrel and also rotate 360 degrees with 3 cameras mounted on that small collar. So with that, these students were able to develop
Incredible.
So this network is about 225 deep, and you see the animation of this network to about
Incredible.
this is 90 deep.
Yeah.
And this has been very successful with the students did it for hardly 50,000 rupees a month, and we do it for. But now this has become a product, and the Ordnance Factory wants it to be implemented for guns with much narrower bore, and that is going to be a huge project. It is still under negotiation. So now coming back to the aircraft systems. So the teams have developed aircraft, these digital twins for airframe structures, environmental control system, electrical system, etc. And this also is a job in progress, which with my last MTech student working on this with their team. The overall hardware platform for the light air combat aircraft looks like this. This is something which can be shared. Other information is a bit. So from the pilot command, it goes to the digital flight control computer. Let me just fill in the blanks. And then there's a computer which is called USMS with beam, brakes and landing gear, hydraulics and engine management, data from these sensors coming to beam, and then ESFM is environmental control and fluid management system. So this data also comes here, and then there is another server and a third server, flight data briefing, HUMS, which does where strain gauge information is stored, and ultimately up to remaining life estimation is done. So, and there's data available everywhere. So this is the hardware platform on which needs to be integrated with the digital twin, which so what we are doing at the moment is with these individual digital twins,
Brilliant.
then go on to an integration at the systemic level to get performance critical parameters and, if possible, remaining useful life estimation. This is, if successful, the idea with Niti Aayog is to repeat this exercise for all the other military aircrafts which are not so smart. Here, this is how the commands flow from the signals flow from the pilot to, and these are the parameters, intermediate parameters, which can be. Now one doesn't know, there is data available, one doesn't know what is input and what is output to a particular system. So in large systems, this is the biggest exercise to identify what is input to the system and what is really output. So this again is a statistical exercise which has been carried out, where we have been able to draw this line diagram for most of the systems. And typically, say for the brake management system, we have a network which through a correlation matrix, we build a correlation matrix of the various data sets that we have, and see it is like finding out cross correlation, finding out the cross correlation function between the various data sets, and then see how it works. Then another network connected to the first network, And then this is with data that has been provided for about 14,000 sorties. 14,000 sorties. So data is required. And you see here that in this graph, we have one of them, the orange one may be the actual data, and the blue one may be the predicted, or the other way around. I don't really remember. Okay. So blue is the original and orange is the predicted. So we are not making predictions in terms of statistical parameters like mean, standard deviation, etc., which is rather easy to achieve. We are predicting the actual values of the parameters, and to our great satisfaction, we are achieving with these networks a success rate of more than 99%, 99.6%, which is the world standard for convolution neural networks these days. So this is indeed 99%, 99.5% accuracy and above for many of these systems. You see this similar thing for hydraulic control, environmentally controlled hydraulic systems, engine systems. Lastly, 5 more minutes. Like the aircraft systems, railways is more complicated because you have several sectors like the rolling stock, the signaling, tracks and bridges, motive power, maintenance, scheduling, telecom. And now data available everywhere and problems galore. For example, rolling stock itself, the amount of data that is available is unimaginable, unmanageable, unmanageable. Rolling stock meaning all the rolling components and rolling subsystems like the bogie. Bogie is essentially the chassis. The chassis, which is called the bogie, the coach, the passenger coach, the wagons, the locomotive, with several of their components. Then you have track management. Track management also, the world over, enormous amount of data is available in track management systems. There are dedicated track management systems developed by groups in Australia, in Spain, in Sweden, that I'm aware of. And we also have some sort of a system, but I'll tell you what the problem is later. Here, if I go back to this, there is data available everywhere, but this data doesn't talk to each other across subsystems. They don't talk across these subsystems. Within the system also, because they have been developed by various vendors, then the vendor has used his own protocol and his own platform, and he has put it under lock and key. So the data does not belong to Indian Railways, but the data then belongs to a person in Malaysia or Japan. Similarly, with signaling, huge amount of data. Scheduling, if you look at this small town where I live, Kanpur railway station, it has 10 platforms which are fed by 32 lines like this, and these platforms are spread out like this. So you have 250 trains coming like this, and 250 trains going like that in 24 hours in 4 different directions. And you have scheduling, which is locomotive scheduling, coach scheduling, maintenance scheduling, rack scheduling. 4 different types of scheduling which needs to be coordinated.
Incredible.
So you often see that you have these trains are waiting in these 32 lines, and the stations platforms are empty because an appropriate signal to be given uh, by the signal man here, because it is all manual. And they all have their schedules. If one train is late by 2 minutes, then one doesn't know which platform to send it on. So it has a cascading effect. So we've been talking of. I'll come to a project in the next slide. And the digital twinning is envisaged like this. Starting right from the component level up to the organizational goals, there has to be integration of information, there has to be integration of data, so that several exercises which have hitherto not been taken up, like optimization, like energy estimation, integration of signaling with track management system, integration of again signaling with rolling stock management system. They are not possible unless data is available, raw data is available on a single platform through whatever means that is possible, either through APIs or whatever. So this is a project that I have recently been asked to advise upon by CRIS, Center for Railway Information Centers. This is Voltaire division in Visakhapatnam, and it feeds three states: Andhra Pradesh, Chhattisgarh, Odisha, and also serves major public sector organizations like, apart from the Navy, Visakhapatnam Port Trust, RINL, this is Ispat Nigam, Indian Oil Corporation, BPCL, HPCL, etc. And there's a huge amount of clogging which takes place here for the goods trains. And the clogging and traffic jams are not like the road traffic jams for maybe half an hour or 1 hour, but they last for 18 hours, 24 hours, 3 days at a stretch, with coaches, wagons lined up and nowhere to go, which is affecting. So this is what the Voltaire railway division looks like, and they have unbelievably, they have huge amount of work has been done in India by CRIS, and they have GIS view of fixed infra, track layers, station layers, yards, maintenance depot. Look, everything is there. They have real-time information system for at every 30 seconds for 6,000 locomotives out of the 10,000 locomotives that we have. We have train running information. We have freight operation information services, who has ordered the wagons, what is loaded in it, how much is loaded, where is it, everything is there. And still we have, this is just 1 week old photograph from Voltaire itself, that this is the jam that is, this red area is the jam in this area. This is Port Trust area, and these coaches have been lying there for more than 6 hours, 7 hours, 8 hours. So this greatly affects the mobility of freight and this is the scenario everywhere, that goods transportation has decreased over the years from 60% to 30%. It has moved to roads. It is all being transported through very, very inefficient, energy inefficient trucks, which are so small in size. They have clogged all the highways. They are environmentally bad, and it is and 50% of the wagons are running empty while they carry, when they carry coal from Bihar to Maharashtra, and they are full. But when they return from Bombay back to Bihar, they are empty because there is no logistics network. All the aloo, gobi, tomato, murga, murgi, that is all being transported, scooters, they are all being transported through trucks on the roads. So this project is a very ambitious project. It has been taken up with the idea that do proper data analysis, make data flow from one portal to another portal, and really find out what the bottlenecks are, what really are the issues in such traffic jams, and how can efficiency be improved, and also energy utilization can be brought down. It is estimated that energy utilization can be brought down in Indian Railways at least by at least 25%.
Oh.
At least 25%. So finally, we have a platform where we can. It is a unified platform for digital twinning. It is called Indus Tantra. Indus stands for, you can take it either industry or Indus stands for India or Indus Valley Civilization, where we provide full stack full stack end-to-end OT IT integration, operational technology on one side and IT on the other. This is a photograph of the ordnance factory where we have recently implemented this Industry 4.0. So the capabilities we also see collaboration from various individuals and groups within Hostel 6 itself on digital twinning, which is database, simulation-based instrumentation, signal processing, predictive maintenance, real-time machine monitoring, tracking, human-machine interfacing, all on one single platform. And as I said, indigenous scheduling and ERP integration and AI powered. This is the digital twin of that rail factory that I talked to you about, with every machine crying and shouting about its state, whether it is on, off, emergency, or whatever. With entire software platform at the base level, physical level, we have has been done for data acquisition layers, has been done in LabVIEW. Translating this also into Python, and the rest of the platform up to ERP and analytics is all in Python. At a very, very economical cost, which can be afforded within the country. This is what the hardware and software protocols look like. This is a human-machine interface also developed by the students. This is a small tab which can be carried by a worker, especially in mining operations where the operations are spread over an entire area, as in Coal India mines, for monitoring human activity. So typical machine loading charts and Gantt charts, which are generated automatically based on the inputs provided by the system, so on and so forth. And finally, analytics, which is application specific, it can be built. Thank you very much for.
This is fabulous. This is absolutely incredible. Incredible. Vyasji, Nalinaksh. So let's open the floor for questions. We've got about 20 minutes. So professor to professor, Anil Saigal, any questions?
It was amazing to see some of those things. I don't think I'd realized just the Voltaire system is so huge. Forget the whole Indian system. Like a small subdivision of India. But no, uh, truly amazing. Also, didn't realize how much you had put all the ML and AI into all these things. So, no, very
Eye-opening, riveting. Yeah.
riveting. Yes, absolutely. No, specific questions. No, just very impressed.
Yeah.
It's all done by our second year and third year students.
Incredible,
Wow.
isn't it? Incredible, isn't it? Yeah. But
Not
Pratap,
not trained engineers, but mostly students who are rather reluctant to work in a sustainable manner. So,
That
so
is
it's
really
actually
incredible. I
it's
can
actually these
imagine Vyas doing it or Cycle doing it, but for the students to do it and for you all to motivate them and guide them, that is really an achievement.
yeah.
incredible. Yeah. Hey,
Well,
Pratap has a question, but Pratap's dad was in railways. So Pratap
Uh-huh.
brings a very unique perspective to the question. Yeah.
My question is something simple. So this RCF Bareilly, Raebareli.
MCF.
Okay, MCF. Sorry, MCF Raebareli. With this increased production, these coaches also would be becoming lightweight, right, and leading to substantial energy saving.
The lightweight actually depends unless you use lighter material.
Mm-hmm.
You cannot reduce the weight. Lighter material like aluminium
Yeah.
involves a cost differential of 8 times.
Oh.
Aluminium is 8 times costlier than steel.
Oh, I didn't know
Oh.
that. Wow.
So,
But from an ongoing energy consumption, that should pay back fairly soon, right? Because it's a one-time cost, yeah, but an ongoing cost for the next 30 years, life of the bogie, right?
but this is what I've been told that it is
A very interesting revelation.
it is expensive. It is essential to save energy leakages in various other at various other points, especially this catenary, which from the supply line itself, there's a lot of leakage.
Okay.
So those points, if that data is available, that should be one of the exercises that we will take up shortly, if allowed to take up.
Okay.
So,
But
just what is the weight of the bogie compared to the weight it carries? That will give us some sense. Like
Correct. Good point.
This is a difficult question. This is
a
weight.
typical bogie versus the typical weight it carries.
The weight it carries is about see, it's 20 tons per axle. Axle load is 20 tons, so
Okay.
20 into 4 is 80 tons is the capacity uh, of uh, of a wagon, a typical Moxon wagon.
Yeah.
Uh, the world over, it has been increased to. It is still not 25 tons in India. They're trying to make it 25 tons of axle load. Rest of the world, it is about 30 tons with much smaller wheels. The issue is the tracks. The coach, the bogie as well as would be around 8 to 12 tons.
8 to 12. Okay.
8 to 12 tons.
So that aluminum saving, even if you got that 1/3, which you will not get 1/3, you might get less than that. It will still be a small fraction.
Yeah, but it also involves a massive change in the manufacturing
Oh
process.
yeah, absolutely. That's
And
the
the
whole.
plant machinery.
Yeah,
And the durability, right? Steel is a lot more durable.
yeah, all that.
Yeah, and the machinery and the plants are for steel and cast iron.
Yeah.
So
Yeah,
the
that's
foundries are all doing cast iron. So
Very cool. Very cool.
I suppose in terms of aerodynamic improvement in designs, it would have
Aerodynamic.
over time.
Yes. So that's the easier part. That has already been done in Tejas and the metro network.
Okay.
So metro is another domain which requires digital twinning and integration for a reduction in the turnaround time.
Yeah. Incredible.
So related question. India produces all the tracks. Obviously, I'm from Bhilai. We produce Bhilai produces all the tracks. What is the limiting in terms of putting the new tracks which might be able to carry this 30 tons per axle?
See this the availability of they're laying down the dedicated freight corridor which has where they're expecting to run at 25 ton axle load bogie at 100 kilometers an hour. But on the existing tracks, the problem is that there is no time slot which is available for maintenance.
Yeah. Current tracks, there's no way. Yeah.
Track availability for maintenance, you would require at least 4 hours of clean time interval when you can do maintenance. So
Yeah.
that is very difficult to. So quite a few accidents have happened because the maintenance work on the tracks is underway and the train has arrived, and the workforce has run away without putting the nuts and the bolts onto the tracks. So incredible. But the Balasore accident also happened because instead of going on the main line, which was where the signal was green, it went onto the loop line because the switch did not operate. The point machine did not operate properly, and it did not switch from the loop line to the main line. And while the signal went on, so one doesn't know whether it is sabotage or bad maintenance or what. So there is a proposal for a very quick development of a smart switch where few other sensors would be integrated before actually the signal goes to the interlocking system.
Wonderful. Nalinaksh, I know it's very late your time. It's 9:30. So we want to be immensely thankful and respectful of your time. Any questions for? I have one, right? You have a very unique perspective being in IIT Bombay, got your PhD at IIT Delhi, and many years at IIT Kanpur. And obviously you've taught lectures. So what are the unique perspectives? What are the commonalities? What are the differences?
Between IITs?
Yes.
Well, every IIT is a different place altogether.
I have a
academically, well, IIT Bombay is still the optimal IIT to be in terms of network and connectivity to the government agencies. IIT Delhi is better placed. But in terms of academic rigor and in terms of academic rigor, IIT Kanpur would be hard to beat.
Wow.
Oh.
Nice.
When I joined in '87, we had there were several stalwarts. There were no roads in the city. the campus was full of potholes. Phone services were not there. And Kanpur railway station was so bad that people used to say, faculty members here used to say that if you were to own both hell and Kanpur, one would prefer to stay in hell and rent out Kanpur. Uh, but but still, this was a great place. It was a great place in terms of the quality of people we had here. It is no longer so, but the quality of people. It used to be the best place in the country to read a book, to write a book.
Nice, nice.
So if you wanted to read a book, you had to be here. Uh, so and the administrative structure was very horizontal here, as compared to Bombay and Delhi. But I did not come here looking at all those reasons. I came here because I was immediately after my PhD, I was offered the post of assistant professor at IIT Kanpur. And IIT Bombay happened after that. They gave me lecturership. Then people told me you will take 7 years to become an assistant professor from a lecturer. So
That's an easy decision.
but then even after coming here, I wanted to run away. Then people told me if you stay here for 4 months, you will never be able to go out. When I came to Kanpur, my friends in Delhi told me it was a big cultural shock. My friends in Delhi told me, "Tu Kanpur kahan ja raha hai? The best market there is worse than Paharganj. In Delhi, why do you want to go there?" And when I came with my wife, I said, "This is the first and last time we are coming. When we came here for a seminar, let's have a last look at Kanpur. We are not coming back here again." But now I feel at home
That's wonderful.
I travel all over the world, but
Kanpur is home. Yeah, home sweet home.
Kanpur is home, which is
Great.
Great.
you start loving you start loving the place wherever you live.
Yeah, yeah.
Wherever it is. There's nothing too great or exceptional about it.
No, that's wonderful.
And Nalinaksh, this was a very
Neeraj bhai, yeah, please go ahead. Yeah, Garu.
yeah, no, it was a very impressive presentation, and working in technology, we are disconnected from these manufacturing realities and the real time actual working systems, and where this technology can play a key role. This was an eye opener for me.
Yeah, absolutely. And the scale.
We should still collaborate on building a platform which brings together expertise, at least in software, and
Right.
the domain expertise. For example, Rajender here, he's quiet, but he has enormous amount of domain expertise as far as urban transport is concerned.
Yeah.
Installation of urban transportation system is concerned. No jokes. He does have.
Well, am I audible?
Yes,
Yeah.
yes. You can't be inaudible.
Okay. I've been, your entire presentation was very interesting to me, because I have touched upon every aspect of the systems that you have talked, leaving the aircraft. So it was extremely interesting, because I have been facing similar challenges in my project in monorail, which is somewhat near the railway projects as well. And one of the very interesting things that we have talked about is that I face challenges like integration between the systems of the trains that you have talked about, the rolling stock and power supply system, signaling and telecommunication, power platform information systems, etc. So I'm wondering, is this kind, when I travel in the trains, I don't see any problem as to the location, as to where the train is, and where when the announcement in the trains are also often made. So in my project, there were a lot of problems in the sense that the automatic platform display system never worked, and
So that is not the problem. The problem is if this is the last question I'm answering.
yeah,
The
last
problem
one.
is
This one is the one.
that if you want to optimize the timetable,
Yeah.
if you wish to these timetables are not optimized. There was a recent study which was done by the former chairman of Railway Board who works with ORF, Observer Research Foundation in Bombay itself. It's a Reliance outfit,
Yeah.
and they came up with a study. Probably you are aware of that. And I have that study with me. That they studied the timetables of the fast trains and the slow trains and the platform timetables, and suggested that with minor tweaking of the platform timetable
Yeah.
and minor tweaking of the fast and slow local timetable, you could increase the number of local trains in 24 hours in Bombay by a number which is equal to 166. 166 more locals could be run in Bombay itself, increasing the number of kilometers traversed by more than 6,000. Only by tweaking of the railway type of the timetable, platform timetable, without any zero investment in infrastructure. So if you want to do that exercise at a zonal level or even a national level, which is going to be a massive exercise, data is not available for processing. Data is available to you for display.
OCCs are not equipped with the SCADA systems.
They are equipped, but the vendor will not give it to you. He will send it to France. He will send it to France. He will not give it to you. And he also does not retain it.
I guess SCADA is working in every metro system, at least. I don't know about railways.
It is working in all metro systems. It is working in railways also. But if you tell them that you give me the data, I've asked similar questions. I am advising Kochi Metro also these days. Okay, I have a formal advisor to Kochi Metro. I'm asking them to give the data from the SCADA system so that we can see the signaling data and look at the track data and look at the rolling stock data simultaneously. It is not available. It's not available.
Is it always that the vendors are different types? That is, like, for example, AFCs and PIDS and signaling systems. If is there not one vendor who will, then we will not have this problem.
They have a stranglehold.
I had 6 vendors.
They have a stranglehold. They have a stranglehold. They will not give you the data, and also they would not allow you to integrate it. Why would they want you to develop this? This is a problem faced not just by us, but I have been in talks recently with a similar entrepreneur in US and one in Australia. The kind of disruption that we wish to make is identical across the globe. That the stranglehold of
they have lot of parameter and variables integration problems.
Companies needs to be broken, and it is not needs to be broken. It is complementary in nature. It is complementary in nature. They have to realize this is a complementary exercise. This needs to be done.
All these signaling systems are communication based signaling systems.
तुम यार दारू पिलाओ अलग से बम्बई में, फिर ये इतना सारा बात करेंगे।
आ जाओ ना, बहुत सारी बात Okay, but before you go,
Excellence.
wait,
Don't
Daru
need
is
a reason.
Daru is always there for you. But before you go, something which is of interest to me these days is usually I do a little bit investing in stock market, and I see the railway sector, exponentially growing. Railway and the aeronautics, aeronautical systems have done. Now all the stocks in railways have already gone up. I have been seeing that you are saying that in terms of the aeronautics, there are some new kind of planes are being developed and which are going up to Mach 2 or Mach 3. You just mentioned some time ago. I want to know if there is any company or similar to HAL. See, HAL has grown exponentially and undergone a split up and all that stuff. So is there a company which is in the making now, where you could get into unlisted market?
Good question.
The stocks which come to IPO, before that there are a lot of concoction goes on, and my study has been that the people, the expert guys, they do all the mustering of the data and the marketing stuff and selling and buying, and in the end they launch it on IPO, where we have to stand in the queue to get something. So, is there some company which is growing up in terms of the railways and in electricals?
You ask Nat. Okay, I am a poor teacher.
No. I'm the wrong guy. Arjun Divechar is a stock guy. I'm a software guy.
No, you know what? You will know that which kind of a new developments are taking place and where potentially some sort of a sister concern or subsidiaries involved in kind of a development which will grow up to come up as an IPO.
Rajendra boss, that requires an entire session. 90 minutes.
Full sessions at least. Each
No, see, I'm asking him because he's the originator of that. Maybe
that's a very good point, but
Okay.
we'll do a special session on that.
Okay,
Then
okay.
Neeraj bhai is waiting in the
Okay.
wings.
That will go to insider info.
When I
Someday
now next time.
insider info, it will get jugged. Anyway, my question was a little bit. Nalinaksh said something about his advice to MSMEs. Maybe a few words on that, because the railway part was so fantastic. I mean, it's such a big complex system that is the sun and these are the small stars which are during the daylight. So anything on the MSMEs, how the IoT business is likely to pan out, or how it's likely to benefit the MSMEs.
So, Ministry of MSME has decided to set up 4 or 5 parks on Industry 4.0 itself. One is going to be in Ambala for skill development and training, and another one I know of would be in Jhansi, and third one would be in the minister's constituency. Minister is Rane in Maharashtra somewhere. So he is insisting that it would be in Maharashtra somewhere. So I know. So these centers are likely to come up. The MSMEs, the productivity has to increase, and the quality also has to improve if you have to face up to the challenges posed by China and Korea and now Vietnam and Malaysia also. Better quality stuff has to come out, whether it is locks or fabric, rubber, coir also. But again, the issue is investment. Once you automate these processes, the control over production would go out of the hands of the. There are about 50,000 households in Coimbatore district itself who would have looms in their houses. and most of them are hand operated looms. If you make them power operated looms, the cost of power is unaffordable by these guys, poor people. So it is a vicious circle. Once you start automating these processes, it cannot be done by the person who is owning the means of this production. Uh, so it is a difficult question and a difficult problem to tackle. These looms, for example, are so rudimentary. Looms in Banaras also for making Banarsi silk, and these looms are, and the carpet making industry in Etawah and such places. They're very primitive, but they are affordable. They are affordable. Once you operate them with power, it goes out of the hands of the poor operator and poor worker. So it needs to be subsidized by the government, but it will have to be done.
True, true.
Fabulous.
Thanks.
Yeah.
Incredible talk. Yeah.
Yeah, nice. So, Vyasji, for your conference in Delhi next year, right?
Yes, I'll touch base with you.
Good. So, if you want to consider as a little breakaway, a heritage walk, say of Lodi Garden or one of these, with a historian, make the
Yes,
place alive.
yes.
And
Yes. So will you take charge of not just the heritage walk, but also a trip to Red Fort in that area, Old Delhi area?
yeah, it can be done, including the whole architecture, marvel architecture. जब हम लोग golden शाहजहानाबाद का पूरा वो come alive with prose poetry, शेर शायरी सब कुछ.
And the good thing is Pratap knows a few amazing historians, and they bring a level of perspective which none of our history books can bring.
We booked India Habitat Center for the time being.
Oh, fantastic. Fabulous.
India Habitat Center for the
Wonderful.
time
So Lodi to hai hi. Red Fort we can see. Yes.
being. Okay.
Cool.
Okay.
Very good. Hey, thank you very much. This was
Nax?
absolutely amazing.
Thank you.
I'll upload the recording on YouTube. I think a bunch of us would really love it.
Nax?
Yeah, boliye.
Thank you, Nalinaksh.
Good night.
Garu was saying
Oh,
something.
yeah.
Garu?
No, I was saying now that we have heard Nalinaksh, now the two other guys that I think we should be listening to is Jasper Lal and also Muzumdar, right? He's also professor.
I know. We'll be. All you guys need to chavi, yaar. And I don't chavi.
He's right. He's right.
It took
He's
me
right.
12 times to get Nalinaksh.
Yeah.
I know. It was just incredible.
It is because of Saturday. yaar.
All you guys need to be drum beaters.
Mazumdar is here in Mumbai, so I will chavi him.
Please, each one of you chavi somebody, right?
Okay, Nalinaksh.
Okay, bye-bye.
Jasper Lal, I don't know. Somebody has to work with Jasper.
Thank you, Natraj, for organizing this. Thank you, Nat, for organizing the lecture.
Thank you, Natraj.
You're most welcome.
Thank you, Vyas. It was such a pleasure.
Thank you, Vyas.